Lesson 8.3 Fractional Expressions. You can turn your books to page 809 if you would like to follow along. First thing is in this lesson is a few vocabulary terms. This would probably be a good chance, or a smart thing to do would be to pause the video. That way you can write these terms down in your notes and then follow along after that. First term is a fractional expression, a quotient of two algebraic expressions. So basically we have a function divided by some other function. That's a fractional expression. A rational expression, very similar, except it is a polynomial divided by another polynomial. So key to remember between those two terms, not all fractional expressions are rational expressions. Last term here is reduced form, a form of a rational expression in which all common factors of the numerator and denominator have been removed. This is why in 8.2 we went through all of those factoring methods, because we're going to see if we can factor the numerator and factor the denominator, because if we find any common factors, we can cancel those out and simplify our rational expression. So for instance, let's take a look at an example. Example, we have x squared minus 3x divided by x squared minus 9. So if we try to factor the numerator, look at what do those two terms have in common. You should be able to recognize that they have a factor of x. So if we take that out, we're left with x minus 3. The bottom you should recognize is a difference of squares. So that factors into x plus 3 times x minus 3. So if we want to write this in reduced form, we're looking, is there anything in common with the numerator and the denominator? If we look, we have a factor of x minus 3 and a factor of x minus 3, so we can cancel those out. If we do that, in the numerator we're left with x, the denominator is x plus 3. There's one condition that we need to write, and that is we put a comma, that's a good comma, put a comma, and we write x cannot be equal to 3. Where that comes from is if we take this common factor that we took out and removed, we set that equal to 0. If we solve, we get x is equal to 3. The reason we need to do that is because if we look at our original denominator, this is going back to domains, that's why we spent so much time on domains before. X squared minus 9 equals 0. So if we simplify that, we get x squared equals 9. Take the square root of both sides. We get x is equal to plus or minus 3. Those are the two values that make this function undefined, so we can't have those in our domain. If we just looked at this part over here where we simplified x divided by x plus 3, right now the only problem with the domain looks like x equal to negative 3. But if these two functions are going to be the same, we have to make sure we take into account the factor that we removed. So whenever you remove a factor, you need to make sure you include that in the domain as well. Okay, there's a lot of information going on there, so if you have questions, if you're writing this example down in your notes, maybe write a question on the side and you can come ask me, and maybe that'll be a little clearer and we can go through that together. The next example we're going to talk about is multiplying and dividing rational expressions. Multiplying and dividing rational expressions is actually easier than trying to add or subtract rational expressions. So if we look at this first example, we have 2x squared plus 11x minus 21 divided by x cubed plus 2x squared plus 4x times x cubed minus 8 divided by x squared plus 5x minus 14. So what we're going to do, we need to factor everything we can in the numerators and the denominators. Okay, so you should go through on your own, pause the video right now, and try to factor some of these. Some of these you'll be able to factor easily. Some of them you might have to look up some patterns, but you should be able to factor these. So pause the video and try to factor them on your own right now. So if you factored all of those expressions, you should have gotten something that looks similar to this. Alright, first one should have factored into 2x minus 3 times x plus 7. The denominator, we could pull a common factor of x out in front. That would factor into x squared plus 2x plus 4. X cubed minus 8 factors into x minus 2 times the quantity x squared plus 2x plus 4. And the denominator factors into x minus 2 times x plus 7. You should be able to see that we have a lot of things in the numerator and denominator that are in common. Because if we're multiplying two fractions, we have the numerator times the numerator, denominator times denominator, so this basically creates one whole fraction. So if we're looking here, we have a factor of x plus 7 and a factor of x plus 7 that we can cancel out. We have a factor of x minus 2 and a factor of x minus 2 that cancels out. We have this factor of x squared plus 2x plus 4, x squared plus 2x plus 4 that cancels out. Many things that cancel out in this problem. And if we do all that canceling, we're left with 2x minus 3 over x. Remember, we have to determine what x values we removed because of our domain. So if I take this factor of x minus 2, set it equal to 0, x is equal to 2. So we know in our domain x cannot be equal to 2. We also had the factor of x plus 7. So if we set that equal to 0, x is equal to negative 7. X is equal to negative 7. We know in our domain x cannot be equal to negative 7. If you would take x squared plus 2x plus 4 and tried to factor those, you would see that would not factor very easily. So you could use a couple different methods. You could graph it. You could use the quadratic formula. Whatever method you used, you would get imaginary solutions. So those do not have any real numbers for the solutions, so we don't have to worry about that when it comes to our domain. So if we used our factoring, canceled out all of those common factors from the numerator and denominator, we can simplify this down to 2x minus 3 divided by x, where x cannot be equal to 2 and x cannot be equal to negative 7. This is called reduced form. The next example is dividing two rational expressions. We have x cubed plus 1 divided by x squared minus x minus 2 divided by the rational expression of x squared minus x plus 1 divided by x squared minus 4x plus 4. If we have a division problem, make it a lot easier and simply turn it into a multiplication problem by multiplying by the reciprocal. So this would become x cubed plus 1 over x squared minus x minus 2 multiplied by x squared minus 4x plus 4 over x squared minus x plus 1. Simply multiply by the reciprocal, make this a lot easier to work with. Again, you should try to factor this on your own. So I would recommend pausing the video right now, seeing what you can factor and eliminate. You're going to have to do this on your homework, so you might as well practice it now. And then you can restart the video after you try to factor and eliminate things to go through and see how you were doing. Okay? When you're done factoring, you should get something that looks similar to this. Again, you should see many things in the numerator and denominator that are going to cancel out. For instance, we have factors of x plus 1 and x plus 1 that cancel out. We have a factor of x minus 2 and x minus 2 that cancels out. A factor of x squared minus x plus 1 and a factor of x squared minus x plus 1. So when we simplify and cancel out all of those like factors in the numerator and denominator, all we are left with is x minus 2. Where, again, we got to deal with the domain. X cannot be equal to -1 or 2. Again, if we try to look at the domain of x squared minus x plus 1, we should look at that. If you would graph this, if you would try to use the quadratic formula to find what those zeros are, you would get imaginary solutions. So we don't have to worry about those when we're talking about the domain. The domain is simply referring to what are the real numbers we can plug into this formula, this equation, and get an answer. So our end result, the reduced form, is x minus 2, where x cannot be equal to -1 or 2. Here's a picture of a dog. Just wanted you to be aware that I am quite an artist. This is the same dog I've drawn since kindergarten. If it ain't broke, don't fix it. Okay, so one thing you didn't know about me, I am a good artist when it comes to drawing dogs. Let's get back to some math problems. I said before, multiplying and dividing rational expressions tends to be a little easier than adding and subtracting, because when we're adding or subtracting rational expressions, we need to have a common denominator. Okay? Just like when you're adding or subtracting fractions, when dealing with numbers 2/3 plus 4/5, you need to get a common denominator. It's often easiest to find the least common denominator, the product of all the prime factors raised to the greatest power found in any one denominator. We're going to go through an example. I think you have an idea of what the least common denominator is when dealing with real numbers. When dealing with rational expressions, it tends to be a little more confusing. First example we're going to talk about is x divided by 3x minus 2 plus 3 divided by x minus 5. In this example, it's almost easiest to just multiply each term by the factor in the denominator of the opposite term. So for example, if I'm taking x over 3x minus 2, I'm going to multiply that by the other denominator, x minus 5 over x minus 5. Then we have plus. Now for the other one, I have 3 over x minus 5. I'm going to multiply that by the other denominator. So 3x minus 2 over 3x minus 2. Now we have some simplifying to do. Use our parentheses because we're going to have to use the FOIL method to multiply many of these things through. So, first one, if I multiply my numerator, x times x minus 5 is x squared minus 5x over, we do not actually, I made a mistake, we do not want to multiply the denominators out. We're simply going to leave that in factored form. And I'll explain why in a minute. And then we're going to add to that. We FOIL or distribute the 3 through the numerator. 3 times 3x is 9x. Minus 3 times 2 is 6. All over x minus 5 times 3x minus 2. Now if we try to simplify, we have a common denominator, 3x minus 2 times x minus 5. That is the same in both fractions. Since we're multiplying, doesn't matter which one comes first, they are still the same value. So if we add those together, we have an x squared term. We have negative 5x plus 9x with plus 4x. Then minus 6. All over 3x minus 2, x minus 5. So now the reason we didn't want to FOIL out the denominator, we want to leave it in factored form, is because at this point we would see if we could factor the numerator. X squared plus 4x minus 6 does not factor nicely, so in this case we cannot simplify this any further. But for future problems, make sure you leave the denominator in factored form. That way when you simplify the numerator and try to factor it, you might get some terms that cancel out. In this case, unfortunately, nothing cancels out, so this is the sum of those two rational expressions. The next example is where we're actually going to use the least common denominator idea. But before we use that, we need to try to simplify this a little bit. So we're going to factor out the denominator. X squared minus 2x has a factor of x in common, so if we take that out, x times x minus 2 plus 1 over x minus 3 over x squared minus 4. If we factor that, we get x minus 2 and x plus 2. So we have to look at all of the denominators. So if we look at the first one, we have an x and we have an x minus 2. If we look at the second one, we have a factor of x, but that has already been listed from the last one, so we don't have to write it down again. We have a factor in the third one of x minus 2. We already wrote that down, so we don't have to write it down again. But we also have a factor of x plus 2. In the definition, it says you need to take that common factor and you need to write it to the highest degree of any of the denominators. Well, if we look at all of the degrees of any of these denominators, x is to a degree 1, x minus 2 is to degree 1, x is degree 1, x minus 2 degree 1, x plus 2 degree 1. So that means all of the degrees are to a power of 1. So all of these will be to a power of 1 as well. We have to take the maximum number from any given denominator. So what we're going to do is try to get it so that all of these terms have a denominator of x times x minus 2 times x plus 2. So in this first one, if we just focus on this first part, if we want to get our denominator to be x times x minus 2 times x plus 2, we need to multiply this fraction by x plus 2 over x plus 2. So I would take my numerator times x plus 2. Since I'm multiplying the numerator and denominator by the same value, I'm not changing the value of that rational expression, we're just rewriting it in a different form. If I use the same idea for the second part, we want it to be x times x minus 2, x plus 2. Again, we got to think about what do we have to multiply the numerator by and the denominator by. Well, we had to multiply the denominator by x minus 2 times x plus 2. So that means in the numerator we're going to have x minus 2 and x plus 2. Now the last fraction, again we want our denominator to be the same, x times x minus 2 times x plus 2. That means the only thing we would have to multiply the denominator and numerator by is the value of x. So that would become 3x. So this is where we're going to use a lot of simplifying, because now we have a common denominator of x times x minus 2 times x plus 2. So this first part, we use the distributive property. 2 times the quantity x plus 2, we get 2x plus 4. In the second one, we would have to FOIL that. We would get plus x squared Those middle terms, we would have negative 2x and a positive 2x. We can write those in, but they will eventually cancel each other out. Minus 4, and then minus a 3x. So if we look at this, now combine like terms. We have x squared in the numerator. So we're going to get rid of that part. Get rid of the x squared. Now we want to look at our x terms. Well, we have a negative 2x and a positive 2x. Those are going to cancel each other out. If we look, we have 2x minus 3x. So that would be x squared minus x. Now those terms are done. We have a positive 4 and a negative 4. Those cancel out. So what we're left with is x squared minus x in the numerator, and the denominator we have x times x minus 2 x plus 2. At this point, we want to see if there is anything we can simplify from the numerator and denominator. Numerator, you should see we have a value of x that we can take out of both those terms. So we have x times x minus 2 times x plus 2. Now we can see we have this factor of x that we can eliminate. So all of this, when we're said and done, simplifies down to x minus 1 over x minus 2, x plus 2, and remember, x cannot be equal to 0. Because if we would set this factor that we removed, that we canceled out, set that equal to 0, x cannot be equal to 0. The last thing we're going to talk about is simplifying compound fractions. A compound fraction is fractions within another fraction. So this looks overwhelming, looks really complicated. If we think about this in terms of the numerator and the denominator separately, take those apart, it's going to make it a little easier to work with. So in the numerator, if we wanted to get a common denominator, the denominator under 3 is just 1, so we need to multiply that by x plus 2 over x plus 2, and then subtract 7 over x plus 2. Okay, so that's how we would have to work with the numerator to get a common denominator. Similar thing with the denominator of this fraction. We would take 1 times x minus 3 over x minus 3 and subtract 1 over x minus 3. Now we need to try to simplify this, make it look a little neater. If we distribute up here 3 times a quantity of x plus 2, 3 times x is 3x, plus 6 minus 7, and that is over x plus 2. Now we're going to do the same thing for the denominator. We have x minus 3. So this is all divided by x minus 3 minus 1 over x minus 3. So we try to simplify this now. Numerator over here, 3x plus 6 minus 7. That becomes 3x minus 1 divided by x plus 2. That divided by x minus 3 minus 1 is x minus 4, all divided by x minus 3. So we have a fraction within a fraction, so that means we can multiply by the reciprocal. we work, I'm going to move my work a little bit to the left over here. We have 3x minus 1 over x plus 2, and now I'm going to multiply by the reciprocal, so that becomes x minus 3 over x minus 4. So again, here at this point, we would try to look and see if there's anything in the numerator and denominator that would cancel out, because in this case, there really isn't anything that cancels out, but there is something we have to add in terms of our domain. X cannot be equal to 3. And the reason for that, if we look at our original problem, what is in the fraction of this original problem? We have to be concerned about this denominator, x minus 3. The value that would make that 0 is 3. And that is why when we come down here to the end, we have to make sure we take that into consideration. So for our last problem, this simplifies down to 3x minus 1 times x minus 3 divided by x plus 2 times x minus 4, where x cannot be equal to 3. That is simplifying compound fractions, which are fractions within a fraction. Now you should be able to get started on your homework. Make sure to ask me any questions over any of these problems you had as you went through the video.